Hello. So this lesson is going to be about trigonometry. Technically, it's going to be right-angled trigonometry. It's the trigonometry of right-angled triangles. But that's the only kind we're going to be doing. We're not going to be doing any other kinds. So we don't have to worry about that too much. Okay, so the first part is going to be naming. We need to name different parts of triangles. So what I'm going to do is I'm going to draw a right angle triangle. So that's our triangle. That's the right angle over there. Now what I'm going to do is I'm going to name. This is going to be kind of, and I randomly picked this angle. There's nothing special about this angle. So this angle over here, that's the right angle. And that one's given. And this is going to be our kind of our chosen angle. And what we're going to be doing here is we're going to be coming up with names for the three sides of the triangle. So we're going to come up with names. Now one of the names you actually already know. So the name for the longest side of the right angle triangle, which also is the one across from the right angle, is going to be the hypotenuse. You may have heard that one before. So that's the length of the longest side of the triangle is the hypotenuse. The next side we're going to name is the one, and if we look at this angle and we kind of look across from it or opposite to it, this side, which is opposite the angle that we've chosen, we're going to call this side the opposite side. So it's opposite the angle that we've chosen. And then the one that's left over, we're going to be calling the adjacent side. So it's pronounced adjacent. Adjacent means next to. So this side is next to the chosen angle. So the names are hypotenuse, opposite, and adjacent. And that's going to be true no matter what the triangle is. So for example, let's draw some. Let's say, for example, this was my chosen angle over here. So this is my chosen angle. This is the right angle. So we first off, the hypotenuse is always the one that's across from the 90. So this is the hypotenuse. And then the one across from our chosen angle is going to be the opposite. And the one next to the chosen angle is the adjacent. So hypotenuse, opposite, adjacent. Or I could, doesn't even have to be like that. It could be, the triangle could be tilted as long as it has a right angle. And let's say this is our chosen angle. So across from that is going to be the hypotenuse. Opposite of that is going to be the opposite. And whatever's left over is going to be the adjacent. So that's naming. That's how you name the triangles. So the next thing we're going to do is we're going to have these ratios. So part 2 is going to be ratios. It's these trig ratios. And they're just going to be defined. And you're going to need, so they're going to be defined as the sine ratio is going to be the length of opposite of the opposite side over the length of the hypotenuse. And the cosine is going to be a cosine ratio. That's going to be defined as the length of the adjacent, all divided by the length of the hypotenuse. And then the third and final one, actually, in grade 10, is going to be tangent, which is the length of the opposite over the length of the adjacent. So that's a lot to remember, so we're going to kind of abbreviate this slightly. So what we're going to say is we're going to say that, so first of all, as a clever abbreviation, instead of saying sine with an E, we're just going to write the first 3 letters, sin, and save an entire letter, which is very exciting. So the sin ratio is the opposite over the hypotenuse. The abbreviation for cosine is going to be, again, we're going to take the first 3 letters. So we're going to say cos, and that's going to be equal to adjacent over hypotenuse. And then the last one, tangent, which we're going to, again, cleverly abbreviate as the first 3 letters. Tangent is opposite over adjacent. And if you ever look it up, there's actually a mnemonic for it. The mnemonic is, it's SOHCAHTOA. SOHCAHTOA. There's actually a great XKCD comic about it. I'll see if I can find it. But the SOHCAHTOA, and essentially this is a way of remembering the stuff that I have in blue there. It's saying sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And essentially, if you talk to anybody who's in any sort of science, they almost certainly know that mnemonic. So let's use this thing now. Okay, so we're going to have, so part 3 is going to be a ratio example. So a ratio example would be, what would it be? So here's a triangle, and we're going to say that the length of this is 5, and the length of this is 12, and the length of this is 13. And I'm going to give it some names. So I'm going to say that the name of this is B. I'm going to say the name of this is A. And we're going to write SOHCAHTOA so we could remember the ratios from the last piece of paper. SOHCAHTOA. It's probably a good habit to get into writing that. So let's say I asked you, what is sine equal to? And so we know, if we're going to name the sides, we know that that's the right angle. So this side is the hypotenuse. So that's the hypotenuse. And which side is the opposite? And we actually don't know which side is the opposite, right? Because opposite what? We don't have that pink angle. So remember when we were naming things, we had our chosen angle over there, and that let us determine what was the opposite. Over here, there's no pink angle yet. So if I say what is the sine, the answer is no idea. Because sine in itself means nothing, and cos means nothing, and tangent means nothing. So that's a silly way of asking things. So the way I would ask it is I would say, what is the sine of A? So if I ask for the sine of A, what I'm doing is I am taking a stand. I'm saying we're going to call this our angle. So if that's our angle, then we know that now this is the opposite, this is the adjacent, opposite, adjacent. And so the sine of A is opposite over hypotenuse, which is going to be opposite over hypotenuse, which is going to be 5 over 13. And similarly, we can figure out cos of A and tan of A. So cosine of A would be adjacent over hypotenuse, which would be 12 over 13. And tangent of A would be opposite over adjacent, which would be 5 over 12. Now let's say I asked for the sine of, are we still on the paper? The sine of B. Now what's happened here is that this is no longer, that's no longer our thing, because we want to know the sine of B. So what's going to happen is we have a new chosen angle. That's purple. I'm not sure if it shows up very well on the video or in this light. But what happens now is, because this is our given angle, then this now becomes the opposite, and this now becomes the adjacent. The hypotenuse stays the same. So the sine of B is going to be opposite over hypotenuse. Opposite is now this, so that's going to be 12 over 13. And of course I can ask for cos of b or tangent of b. And that's cosine of b is going to be adjacent over hypotenuse, new adjacent, so it's going to be 5 over 13, and tangent of b is going to be opposite over adjacent, 12 over 5. Okay. And we'll never pick c, like I'll never ask for the sine of c. We only do it for the other angles. And there'll be reasons for that, but you won't really learn that in grade 10. You would do that in grade 11 potentially. When we do graphing stuff, we'll have a better idea of what this involves. Okay. So before we move on to the examples, we are now going to, before you go to the next video, you're going to go and grab your calculators.